Hello folks, welcome all of you to the Global Coding Cohort. I hope audio and visuals are fine. If you face any difficulties, please let them know in the comments. Yesterday we learned about inheritance and the types of it. If there are any new viewers, please make sure that you watch all the previous videos. Go to my channel under live section. You can see all the previous live streams saved over there. And the code files that we use in this live section will be uploaded to our GitHub repository. A link to our repository is given in the description of this slide. And this is the last session where we will learn Python basics. And tomorrow onwards, we will start solving beginner level coding questions. Okay, so you can start submitting uh, any problem statements in the form. A link to the form to submit problem statement is given in the description of this live. You can find that link. Go to that Google form. You can submit any problem statement for which you would like to get a solution. Okay, it might, that may be any question that you get in your colleges or in an interview. Any question you can submit it in that form, and I'll be taking your questions, your coding questions, one by one, and will be giving a solution to those in this live section. Got it? And your doubts, if you want to talk to me regarding your doubts, uh, if you need, you can in the last 15 minutes, you can let me know through your comments so that I can start the Telegram meeting. So you can directly talk to me. I can clear all your doubts over there. Today, let's start our session by learning decorators. To understand this, let us assume a scenario uh, where we need to calculate the time of execution of a function. In the previous sessions, we learned functions as let's use that function and learn decorators. And for that, uh, I will start writing function called calculate execution time. Our task is to just assume a scenario so that this is an example scenario to learn decorators, the use of decorator, application of decorators. Okay. Uh, okay. Function. I will explain what this function will do. Okay. First of all, let me write it. Mm. And here we will also use, yesterday we learned how to use star arcs and double star quarks. And we will use that concept as well. So we will be using different concepts that we learned in the previous sessions. That's why I told, if there are any new viewers, please make sure that you watch all the previous videos. If you don't know Python, okay, if you already know Python, no problem. We can continue from here also. And before that, I will import the package. Not speed. Or else total time. So this is the function that we are going to use this as decorator. Okay. Because we'll be passing different functions to this, and we just want to know the execution time of that time for that particular function to run. Got it? And this is a method which we will be using as this name as a decorator name, and this is the function that this decorator would return over there when we run, when we use this as a decorator. Got it? Now we will write the function, some random function. Okay, function. I'm going to have a n over here, and then just simply going to do some operation over there. Okay, just for example, I'm doing this. Okay, and finally we'll delete that variable itself. Just to show an example scenario, I'm using this execution time calculation as an example. Okay, there can come any different scenario also. Okay, this is just a normal function. If you run now just by giving 5, then nothing will happen. But when you call this decorator function over here, and now execute this second cell. Now when you call, you can see, sorry, execution. Okay. Now you can see execution time is given here. Now let's change the uh, okay 10 or 100,000. So execution time is returned. Uh, this is just an example scenario I used to explain this decorators. Okay. I hope all of you are taking notes along with me. That's I'm leaving the gap. Whenever, just note that whenever I leave a small gap, even if I do not tell, you have to take notes at that time. Okay. Take notes in a way that you understand. Even if you revise that, when you revise that portion later, write it in a language, write it in a way that you understand. You should understand the concept when you look at that later. This is just my example scenario. Okay. In this place, I can use some other thing also. Uh, okay, this thing. Let's create another function called okay, some random function. Print sample status indicator function. Then nested arts. This is example 2. Okay, Cohort. Just for understanding, I'm doing all this stuff. Print started. Start. Okay, no problem. Start. Then function execution start. Okay, then function print execution end. Next step. Now if you give this, let's copy this same code. Now if you run random function, then you will see something like this. You are getting the status. Okay, in this place, if we simply give sleep, then you can see that execution end will get printed after the end second. Got it? See, now you got only EXEC start. Only after 5 seconds. So that's why we just wrote that status indicator as an decorator. Okay. So understood the concept of decorator, the application. I hope you understood. Now let's move to the next concept. Okay, take notes in between. Next concept is polymorphism. Polymorphism means uh, let's consider there is a function or method, same method but behaving in a different ways. Uh, let's example from 5. This behaves whenever we call, this behaves in the same way. But if this behaves differently, instead of printing hi, if this said hello, then we can understand that this same sample function is behaving differently. Isn't it? Here, this sample function behaves same in all situations. Now let's see. Yesterday we learned a class and all, isn't it? Okay. Now let's in the class. mm, Method A. Okay. Method A. Print A. And now let's create class B and let's inherit this A over here. Okay. Okay, let's leave it blank, no problem. Now let's finish. Okay, the B. Okay, B off. Sorry, caps B off. Let's issue it A also. Okay, object for A also. Now you can see can be A dot method A throw A is also A. Can the B, we can access the method of parent also, isn't it? So when we access method A, here it's behaving same. Polymorphism means, let's copy the same code. We can override the same method of parent class. Now if you instantiate call, you can see the same method, though it received, though it can access the method A, now this function has overwritten the function that it received from its parent A. Got it? So same function may behave in different way. This method A belongs to class A, but as it is overwritten. In other languages, I think it will be here override something will be used and will be overwritten. But in Python, we can just like this also do the same, do this operation. Got it? This polymorphism can also be achieved through another concept called abstract class. Abstract class is nothing. If the class has abstract method, then that class will be called abstract class. And Python directly do not support this feature abstract. So it has but here given a base to build it. So its name is ABC. We are not just as taking it as an example. This library is actually provided by Python itself. Got it? ABC as ABC to create abstract class. So a class with abstract method is called abstract class. So we import abstract method from ABC library. I'm going to use this inside it. Class A let's use the abstract method over here. Just before we learn the declaration, and this is to teach this concept only. At first, I taught you decorator. What is abstract method? Method is fast. For example, you are in a team, and your team leader has framed some relation between the classes and has given you the task to write the lines of code which will come inside this method. So at that time, what can you do is you can inherit the child class from your parent class A, then you can overwrite that. Then how to instance use the constructor also. So from I from okay. Now let's call. Okay, I will show you. Okay, I will show you the scenario also. Previously, we were able to create an object for A, and we called successfully the same method A from 10B also. But here I will show you the difference. So that's why we are just creating an object only for class B. Class B dot method A to front. But if you try to create, okay, not if you try to copy, we have to abstract method. We have to call a parent also. We have to inherit from that parent abstract class. That is the base. Okay, ABC. That is the pair. The class A. That means your project's parent will be inherited from Python's inbuilt ABC. ABC is provided to the user to create abstract classes. Okay. as it directly, as Python do not directly support, as Python do not directly support this feature, this base library is provided to us. Okay, it's called ABC is provided to us. So now when you okay, B will get executed as usual, but when you try to execute A off, that means when you try to create an object for when you call class A, then you will get an error. Can't instantiate abstract class A with abstract method. Got it? That means abstract method cannot be called. We cannot create an object using this abstract class. What is abstract class? Met Class having abstract method is called abstract class. Got it? So understood the difference? So okay, take notes. Hope you have completed taking notes. Now let's move to the next concept, time and space complexity. So this is an important part, not just in computer coding, but also in your software development or your IT career itself. When you write code for any application or a project, your code should have various good factors. There should be good readability. Readability factors we will see later. But the most important thing is your code should run fast. This is the most important. It should run fast. There can be a different many solution for a single problem itself. But you should at last you should choose the best code that you have written. Best code means best solution. There will be different ways to solve the problem, isn't it? Way one, way two. But if way two is running faster than way one, then you should probably choose way two. If you are focusing just on execution time. Got it? And how do we can also we can also measure time of any uh, function of class just like this also direct time. Okay, we'll get how much wall time. So this is the total time CPU plus IO time. This is the wall time. This is the real time. Okay, let's do the time dot sleep of 2 seconds. Then you can see the time 2 seconds. Other means millisecond, nanoseconds. If it got executed very quickly, you will get that exact millisecond or nanosecond, whatever it is. You can also check like this. This is wall time, checking the wall time. Okay, but without running a code itself, if you want to evaluate a code's time complexity, this the concept of time complexity will be helpful at that time. Sorry. Okay, you can also use the previous method which we saw here to see the execution time, and this is also another way. Okay, but this will get supported only in notebooks. Okay, notebook files. Understand this concept very well. Very important. The next factor is space complexity. two factors. Both should not be compromised. Your code should run fast. At the same time, it should not also it shouldn't use more RAM also. If it's necessary, if there is no other way, it has to use it. Then in this case, in that case, that's okay. But if there is a way for you to use less space to do the same operation, means if your concern is only space, then you should probably go with that algorithm which use less memory to finish that process. If if your concern is both time and space, then you should go with the algorithm that is not using much time and much space. That means you should choose an algorithm that runs fast at the same time, which uses less memory also. Got it? It should use less memory and it should run fast. Got it? So now let's see how to find time complexity of any algorithm. Now let's have 10. Let's have a small code. I in one, sorry, just 5 will do. 5 means this loop will run 5 times, isn't it? 5 times. What are we telling? 5 times. So when I taught you the concept of looping, what did I tell you? Here, this line is running one time. Even if you have 1,000 lines of code, something like this, you will come this all this line of code will run one time, isn't it? One time. All this code will run one time. It will not loop, isn't it? It will not loop something like this. So when you want a piece of code to execute more number of times, we will choose to go with loop, isn't it? So the time complexity of an algorithm is calculated directly by seeing this. So for this example, to calculate time complexity, this is a loop, right? Here you can have n number of code, and understand that the code here may take even 1 hour or 1 minute or 1 second. It may take any number of duration to get executed one time. It may take any number of time. It may take even 1 hour sometimes. It may take 5 minutes or 1 second or 2 seconds or 0.5 seconds. But irrespective of that, you should count. Okay. How means? Now this code totally takes 25 seconds, but the time complexity of this code is, we will mention that with big O of n. And big O means the worst case. There are best case, average case, and worst case. But the mainly we will consider worst case because best case is also important. I do not say we have to neglect that. No, we shouldn't, because in some cases, for example, okay, you are given a task to sort an array. Okay, sometimes your algorithm might be trying to sort an array which is already sorted. So if I'm giving an input of sorted array, and your function to sort any array is running over that for some time, then it is waste of time, isn't it? So in that case, best case is also getting its importance. But major, first of all, we have to focus on worst cases. Okay, because when I give an unsorted array with 1,000 size, that means array with 1,000 numbers of which are unsorted in that list, in that array. Okay. So in that case, you have to give, you have to check the worst case. If an algorithm is performing best, if an algorithm, uh, hear this line properly, clearly, if an algorithm is performing best, even in worst case, then that is a good algorithm. Understood? If an algorithm is performing its best, even in worst case, then obviously that is a good algorithm, isn't it? So that is what is represented in big O. So we for this piece of code, for this 4-line code, our time complexity is big O of n. Why n? Here I can change. I may change it to 10. I may change it to 1000. I may change it to 100. Any value I will give it over there. Okay. But what is n? If n is 10, then this code will take 10 loops. This code will run 10 times, right? If I give 10. So that is what. So we cannot change simply always. That's why. What is n? This code will run for n times. So that's why it is known as O of n. Got it? Now, for instance, just take this code, uh, example of O n. Okay, example of O n. Now you will see example of n square. N square. And square, I am mentioning it with a cap symbol. N square. You should read it as n square. Okay, n square n equal to 5. Just assume this algorithm will run 5 into 2 times. That means when n is 5, this algorithm will loop 10 times. Then this algorithm is designed to work in such a way because we have a specific scenario to be solved. So this algorithm works in that specific way. So in this way, this code, when n is 5, this code runs double the time of n. So when I give 10, sorry, I have, instead of giving n into 2, I will give 5 into 2. Okay, this is the algorithm. Okay, it will run 20 times. If I give 2, it runs 4 times. If I give 100, it will run 200 times. As it's starting from 0, we are seeing it as 199. Okay, starts from 0, isn't it? So this is what is the case of n square. So now we will say the time complexity of this particular algorithm, this piece of code is n square. Now let's see another scenario. Example, n plus n square. Or it's no problem. Let's keep it as something like this. N square plus n by 2. Actually, for to show an example, I am typing at first itself. I know I'm going to write this code in such a way that its time complexity will be like this. But in real time, First you will write the code, then we will calculate. Okay. Okay. Now I will leave space for that. And show it. If I think like this, I can copy the code. Now for this code, if I give 5 as input, assume this n is input. Okay. If I give 5, assume that the these code that are present within the loop, this is also a code, right? Uh, this is also a line of code. Given n is, this is also a line of code. This also have a execution time to get it executed. But we will consider altogether as constant one, a constant one. All lines that execute one time. For this code to get executed, it is one. Okay. It is. It's not that we should have only one. You can also have multiple lines of code within this loop also. But we will consider the entire thing as one. And here also, we will have some line of code. We will consider all together. We will consider all this normal lines of statements as one. Okay, all together. The, the lines so 2, 3, 4, line number 6, 7, and 9. All together we will consider as a constant one. Let it take no problem. Let it take 1 hour or 1 minute or 1 second. No problem. We will take that as a constant. That means it will take some constant time. As in it is some take it will take constant and a constant. Okay. This constant is not just applied over here. It is also applied to all. Here for line number 2, 4, 5 take a constant. Let us assume that means in the best case if I give 1, it will run for 5 seconds. But let us consider that as a constant. Okay, because we are not considering the wall time. We are just calculating it algorithms and algorithms time complexity by seeing the loops. Okay, we are not actually calculating the wall time. To calculate wall time, we can use these percent time or the previous technique which we saw in the start of this session. But here we are going to, but when we have such an opportunity, such a feature, you may ask why is it calculated like this? Actually, it is calculated like this. This is a standard that we follow in our development career to know because while writing an algorithm itself, you should know the developer should be able to measure. That means a normal user, if you're just a naive user, if you don't know anything, you can go and execute that and understand. That means, but to understand the time complexity of a code, you have to try with different sample inputs. Okay, that means see, if you are a non-developer, then for you to understand the time complexity of code, first you will try with 1, then you will give 10, then gradually you will keep increasing the input value and will see the execution time, how the execution time changes. Listen, after you record all the, okay, for when I give 1, it take 1 second, when I give 2, it took 2 seconds. So after seeing all these, after collecting all these, what trials, record all these measures from the trials, you will understand. But when you are a developer, before executing code itself, you should be in a position to understand the time complexity of it. Got it? And that's why these concepts like big O notations are formed, framed, and taught to us in our colleges itself. Understood? So, like I said, all these lines of code, let it take 1 hour or no problem. We will consider that as a constant. and see the number of times it gets executed. In this case, previously we just had only one loop, isn't it? But in this algorithm, we have two loops, and one runs for n square times. That means when n is 5, it will run for n square times, and for here it will run. Sorry, I did a mistake. This is not n square. Okay, this is not n square. 2n, 2 into n. Its time complexity is 2 into. Sorry guys, sorry folks. This is not n square. This is an example of 2n time complexity. Okay, 2n. Got it? This is an example of 2n. Because when you give 5, it is executing for 10 times. It is running for 10 times. That means 10. When you give 5, it is getting executed for 10 times. 2 into 5 is 10, isn't it? So 2n. Our input n is 5. This is 2n. Example of 2n. Okay. And here, okay, in this same example itself, let me try to give you the example of, we didn't see n square, isn't it? Okay, let's see an example of n square also. Alright. AJ. Okay. Okay. This piece. Okay. Okay. Here we can see a nested loop and a normal loop. Understood? So that's why we are going to, okay. First of all, let's run it and see its output. What you can see? You can see hi, given n is 5, 0, 0. You can see it got executed this many number of times. So it is simply nothing. This line will run 25 times if you give 5. You can count it if you want. You can just manually count it and cross check it. This should have run 25 times when we give 5 itself. Let's try with different value. You can see it has got executed 4 times when we give 2. So this is the case. So when we give 2, this loop is getting executed 4 times. Then what we can infer from it? We can observe it is running 4 times when we give 2 means it's double the time it is running, isn't it? Double 2 times. Double the time of n. So that's why we are going to consider this as n square. Example n, n square, and we are adding plus. Why? Because we are having another loop as well here. So we are adding a plus over here in this expression. And how is this running? When we give 2, this is output of second loop, isn't it? So when we give 2, it is running for 2 times. When we give 5, it will run for 5 times, isn't it? So that's why we are going to give n over there. So the time complexity of this algorithm, this this algorithm is, just assume it to be an algorithm. Okay, just for understanding, I am writing a basic code. So it is n square plus n. Got it? If you have written something like this, change it to 2n. This is not an example of n square. This is an example of 2n. Okay, because when we give 5, this will run for 10 times. That means when will we get 2? How do we get 2 means when we give 5, it is running for 10 times. So 2 into 5 is what is 10, isn't it? 2 into 5 equal to 10, isn't it? So that's why we have created this expression. And like this, based on the count, we can create any number of any type of expression like n cube plus 3 or n cube plus 5 or n power 10 plus 1. or n plus 1 or n plus n by 2. Okay, now let's see an example for n by. Okay, first let me write the code. To teach, I am planning to write a code something like that to show a scenario, additional one more scenario. Okay, 5 by 3, sorry, 2 equal to 5. So here, when we give 5, it is running for 2 times. When we give 4, it's running for 2 times. When we give 3, it's running for 3 times. When we give 2, sorry, I didn't give any over here. Okay. When we give 5, it's running for 2 times. When we give 4, it's running for 2 times. When we give 3, it's running for 1 time. When we give 2, it's running for 1 time. When we give 1, it's running for 0 times. What can you understand from this? When we give 5, it is running for 5 times. But also when we give 9, it will run for 2, 3, 4, 4 times. When we give 8, it's running for 4 times. But how? Why? Because we are just when we give 9, as we give double. I hope all of you know how this double slash works. Because when we divide 9 by 2, we will receive the same 4. And when we divide 8 by 4, divide means double slash. Okay, using double slash, we will receive the same 4. That's why in both cases this is running for 4 times. But what can you understand? 8 means 4 times. 8 means, sorry, 5 or 8. Okay, no problem. Let's take this 8 itself. 8, when we give 8, it is running for 4 times. When we give 8, it is running for 4 times. What can you understand? Half the time it's running, isn't it? Okay. So can we write something like this? 8 by 2 is equal to 4, isn't it? So can we replace this 8 with 10? Yes, isn't it? So the complexity of this code is example of n by 2. The complexity of this algorithm is, assume the stick algorithm, this is a basic code. This algorithm is O n by 2. Got it? I thought of finishing the basics today itself, but already it's 1 hour. Okay. Okay, no issue. We will see the rest of the part of Python basics tomorrow. And tomorrow itself, we will also try to start basic beginner level coding also. Okay. So that's it for today, folks. See you tomorrow, sharply at 8 p.m. Go through all this portion. Be clear with the basics so that you can boldly move forward and crack any coding interviews. Got it? So thanks for watching. See you tomorrow. Bye bye.